This is our major project, and we are from the IT department. Our major project is about the development of a clustering algorithm for wireless sensor networks using fuzzy logic. Uh, what we are doing this project under the guidance of Dr. Padmalaya Nayak ma'am, and our team members are Manisha Bajawar, myself, Soundarya, Karpi, Keerti Yadav, and Anita Taniru. So, what is our project exactly about? Our project is basically a research based project in which we are going to study about the protocol and its behavior and compare between certain parameters that are given to the base station. So, now what is it exactly? Our project is domain is basically networking. So, in networking, we are studying about the wireless sensor networks, and we all already know what are wireless sensor networks. They are nothing but a network between the sensor nodes, where the sensor nodes are those devices that sense certain information and send it to the base station, which again sends it to the other application stations and use these information for a huge range of applications. mm, so our objective is now to develop an algorithm for a protocol called leech, uh, and study uh, its effect by simulating it on a network simulator. So basically, leech, what is a protocol? Protocol is nothing but how the information is transferred between the sensor nodes in a wireless sensor network. So here leech is one kind of a protocol which forms clusters between the sensor nodes and then selects one of the cluster as the cluster head, by which all the other sensor nodes or all the other clusters send the information to the cluster head, and from there to the base station, and so on. This is the way how communication happens between the sensor nodes in a leech protocol. So our objective again, coming to our objective again, is to focus on developing an algorithm in the selection of the supercluster head for the clustering protocol leech. So here we are going to select a supercluster head out of all the other cluster heads using a logic, which we are going to name it as fuzzy logic, and then see the results. So this is the existing system versus the proposed system. In the existing system, which is already there, is it talks about just selecting the cluster heads among the clusters formed in a leech protocol, and from the all the other in a cluster, the sensor node send the information to the cluster head, which in turn sends it to the base station. So this is how the communication happens. Whereas in the proposed system that we are going to propose, out of the cluster heads that we are going to select in each cluster, a super cluster head will be selected, and all the other cluster heads communicate to that super cluster head, which in turn communicates to the base station. So again, I've already told you about wireless sensor network. um, Sensor networks consist of sensor nodes, which are also called mote. They are small, lightweight, portable devices with a transducer, microcomputer, transceiver, and a power source. The transducer produces signals based on the sensed physical phenomena, and the microcomputer processes and stores the sense information, whereas the transceiver receives the instructions from the base station and sends data to it. So what is the leech protocol? Again, in detail, um, it is a hierarchical clustering algorithm for sensor node, and the full form is low energy adaptive clustering hierarchy, that is leech. As I told you, in leech, sensor node form clusters, out of which a cluster head is selected, which sends information, which collects data from all the other clusters and sends it to the base station. So this is how the development of an algorithm for leech is done. You select cluster heads based on threshold value, then select a k optimal ch in each round. Round means the number of times a cluster becomes the cluster head, and all the cluster heads sends the aggregated data to the supercluster head. According to our project, the supercluster head will be selected using a fuzzy logic. then how the fuzzy logic designed and implemented. This is how it is done. We are going to take three parameters based on which the super cluster head will be selected among the cluster heads. The three parameters are battery power, that is the power of the clusters or sensor nodes. Then the distance to the base station, that is the distance between each cluster head to the base station. And the edges means the neighbors, the number of neighbors that lie around a particular cluster head. So we need to note that in a cluster, every cluster or every sensor node becomes a cluster head at a particular interval of time. So there every cluster head, every cluster or a sensor node takes chance to become the cluster head. So using these three parameters, we select the super cluster head, and this method is called fuzzification or Mamdani rule. And based on these three parameters, we see that which cluster head has the highest chance to become the super cluster head. So now another important aspect of our project is that we are going to introduce three types of mobility. Mobility is nothing but that movement. So here we are going to introduce mobilities to the base station, which means that the base station will be moving throughout the process of communication and simulation, and it will be collecting data. So we are giving three types of mobility. Means it one mobility, which is random walk, the base station will be having a particular source and destination, and it will be moving using a random speed and direction. The other one is random waypoint. In random waypoint, what happens is, again you have a source and destination, and but it chooses random points between the source and destination to wait for a particular moment of time at those random points, and again random speed and direction, using them it moves to collect data packets from the supercluster head. Random direction is nothing but, in this it has a source but no destination, and it keeps traveling with using a random direction and speed. So this is how simulations happen. I'll also be showing all this in the execution part. And this is the performance analysis, that is nothing but how we are going to analyze the uh, simulations, and using X graphs we generate them and then analyze. So these are the system requirements of our project. Hardware are 4 GB RAM, 64-bit OS structure, an i5 processor, and software is Ubuntu operating system and an NS2 simulator. So yeah, this is the conclusion. But before conclusion, I would like to say that in our project we are going to introduce three types of mobilities at the base station. We are going to develop a algorithm for leech using a fuzzy logic, by which we are going to select a super cluster head among the cluster heads, and then we are going to compare between the three types of mobilities. We're going to introduce the mobilities at the base station, right? So between the three mobilities, we're going to compare and see which is better. So that is our project conclusion. According to our work, is what we have found is that random direction mobility model performs better than the other two models. So now I'll be showing you the execution. This is Ubuntu, and I have opened Ubuntu using the VMware workstation. I'm using a virtual machine to operate Ubuntu on my desktop, and entering the password to log in to Ubuntu. So I have already run my project. Like, this is my folder containing all the programs, and main program that I'm going to run is main.tcl. How do I run it is nothing but like this. First I set the path for that main.tcl. This is the path, and then I run the main.tcl file using this command, which says ns space main.tcl. On entering that command, I get three options to select which type of mobility model I want to run, either random walk, random waypoint, random direction, or compare the three. So we cannot compare directly. I need to run all the three mobility models first, and then only I can do the comparison part. So 0, 1, 2, 3 are the choices. I enter the choice, and this is what this is the data or the some of the results that I get on the command prompt. And by this a network animator is also opened. I'll just maximize this. I'll zoom it a bit. So these are the sensor nodes. Basically what we are trying to do is we are showing the real what happens in the real world in the virtual in a virtual way using this simulator. This is network animator, which is available in the network simulator NS2, and our NS2 version is NS2.34. So I zoomed and I decreased the speed completely. Now I say play. So I can now increase the speed a bit so that I can see some kind of communication happening. So if you can observe, the this is the base station. I have set the 15th node as the base station. um, all this, how to place the nodes at their respective places, how the data packets are sent or delivered or received, and how from where to where it takes place. Everything is we have written an algorithm for it using the TCL script. So we have written a code for that. So this is how it happens. The base station is moving. Now I have selected random walk as my mobility model. So you can see that this is the base station and these are the data packets. I'll just slow the speed so that you can see the process clearly. So these black dots are the data packets that are being sent. First, this is one cluster, this is another cluster, and this is another cluster. So each member of the cluster sends the data packets to its respective cluster head, which in turn sends the data packets to one of the cluster head out of all the cluster heads in each clusters. So here 1, 2 and 3. There are three cluster heads selected, but out of these three cluster heads you can see only one is the super cluster head. So all the other cluster heads send the information to this super cluster head, which in turn is sending the information to the base station. If you can see clearly, now in this 1 is the cluster head, 8 is the cluster head, and in this 11 is the cluster head. All the other sensor nodes are sending the data to their respective cluster head, which in turn are sending the data to the super cluster head, which in turn is sending the data to the base station. So this is how the communication happens. Yeah, so this is how it happens. I'll just stop the execution part. So this process you can repeat for all the other models by selecting 1, 2 as random walk, random waypoint, random direction, etc. You can see the similar way. In the similar way, you can see the simulations for the other two models also. Now each model generates its graph. So first is the energy, which is the average dissipation energy versus the time. So how the energy decreases in terms of time for all the nodes present in the network simulator. So it was initially I gave 100, it keeps decreasing as it sends its data packets to the base station, and finally it reaches the desired value, which is very low. The next graph I have generated is the packets received at the base station versus time. So how many packets are received at the base station at a particular interval of time. So that is what is shown by this graph, and the other graph is it talks about the alive nodes versus time. So these are the number of nodes I have. You can increase the number of nodes. I have taken 15 nodes with 3 groups. So how many nodes are present at a particular interval of time and how many are alive? So all 15 nodes are alive till almost 45 seconds. Then they keep decreasing because they lose their energy and they become exhausted and finally die. So these three graphs are generated for every mobility. After I run all the three mobilities, I'm going to close all of them. I'll just close every graph so that I can see the comparison graphs generated. I run the program again. Now I enter my choice as 3, which shows me the comparison graphs. So these are the comparison graphs. So again, coming to the alive nodes versus time, if you can see, random direction is blue, random waypoint is green, and random walk is denoted by red colors. So if you observe clearly and if you plot every value for every particular interval of time, we observe that random direction, which is the blue line shown, performs well. Even for energy, average dissipation energy, even for packets received at the base station, which means that when the base station travels using the random direction model, the energy dissipated is, the nodes don't lose energy so easily. The packets received at the base station are in a great number and it takes place in a faster manner. And the alive nodes, the nodes the alive nodes, number of alive nodes, that means the number of nodes that remain alive are are a greater number. For a greater amount of time the nodes remain alive and they don't lose energy so easily when the base station travels with the random direction mobility model. So this is how we have performed the analysis. We generated the graphs and we have documented everything, and seen the results. So our conclusion was, I'll just close the Ubuntu. So our conclusion was, according to all the values taken, the graphs generated, that random direction mobility performs better, way better than the other two models. And our future work is nothing but to publish this analysis and all the results that we have obtained in a paper, and also maybe design another protocol and compare it with our protocol that we have designed now. So that is our work and this is our major project. Thank you so much.